Hello everyone and welcome to day 52 of our low-level design course. Today we are going to dive into an essential but often underemphasized aspect of system design, handling errors, logging and monitoring. These practices are vital in ensuring the robustness, reliability and observability of your system. By the end of today's lesson, you will not only understand how to handle errors gracefully, but also how to capture system events through logging and monitor the health of your system in real time. Let's quickly review the key topics we will cover today. We will begin with why error handling is important in any system and how you can design your system to recover from failures without affecting the user experience. Then we will dive into logging, which is crucial for tracking system activities, debugging issues, and gaining insights into how your system operates. Lastly, we will explore monitoring. Monitoring involves tracking key metrics to ensure the system is running as expected and allows you to identify issues early. This session will arm you with the foundational knowledge to implement these techniques in your own designs. Error handling is something many developers overlook, especially when their systems are running fine. However, in real-world applications, errors can come from many sources. For example, user errors such as invalid input can easily break a system if not handled appropriately. Similarly, system errors like database or network failures can cause crashes or inconsistent behavior. And of course, programming errors such as null pointer exceptions or array out of bound errors can derail your application. Therefore, error handling is essential to prevent crashes and to ensure the system behaves predictably even when something goes wrong. Now that we understand the importance of error handling, we must choose an appropriate strategy. One key decision is whether to throw or catch exceptions. When you throw an exception, you are signaling that something has gone wrong and you cannot continue with the operation. On the other hand, catching exceptions is about managing those errors in a controlled manner, ensuring that the system can continue to function. A good practice is to define custom exceptions for specific scenarios. For instance, if you are building an e-commerce system, you might have exceptions like payment failed exception or out of stock exception, which give much more context than generic exception messages. You will also need to decide between the two main approaches to error handling: fail fast and graceful degradation. In critical systems, you might prefer to fail fast, immediately stopping when an error occurs to avoid further damage. However, in user-facing applications, graceful degradation is usually the better approach, allowing the system to recover or function in a limited way while maintaining user experience. Exception design is a crucial aspect of error handling. When designing exceptions, make sure to throw exceptions that are meaningful and domain specific. For example, instead of using a generic exceptions like exception, consider throwing something more descriptive like payment processing exception or invalid user input exceptions. This makes it easier for other developers to understand the problem and take the necessary action. Furthermore, you should propagate errors with relevant context, include useful details like the error code, user information, and a timestamp. This way, if the error needs to be debugged later, there's enough information to pinpoint the problem quickly. Finally, when catching exceptions, always ensure you preserve the original stack trace. Wrapping exceptions is an excellent practice to capture and maintain the full context of the error without losing the crucial debugging details. Logging is an essential tool for monitoring and debugging. Think of it as a window into the running state of your system. Proper logging can help you trace issues and understand how your system behaves under different circumstances. There are various logging levels you can use: debug, info, warn, error, and fatal, and it's important to log the right amount of detail at the right level. For example, debug logs are for detailed information useful during development. Info logs give you general information about system operation. Warn signals potential issues. Error is for actual problems that need attention, and fatal indicates a critical failure that likely crashes the system. Properly using these levels ensures that logs are not overwhelming but still provide meaningful insights into the system's health. Good logging practices go beyond just choosing the right logging level. One key practice is to avoid logging sensitive information such as user passwords, authentication tokens, or personal data. Logging these details can create significant security risks if your logs are accessed by unauthorized parties. Additionally, structure your logs so they are easy to parse and analyze. JSON is a preferred method because it's machine readable and allows for better filtering and querying. Another tip is to use established logging frameworks like Log4j or SLF4j. which provide features like log rotation and centralized logging. These tools can help you manage large volumes of logs and avoids issues like log file bloating or missing logs. Now let's turn our attention to monitoring. Monitoring is about tracking the health of your system in real time. While logging provides a detailed view of system events, monitoring gives you an overview of key metrics that help you assess if your system is operating as expected. Common things to monitor include error rates, response times, memory usage, and CPU utilization. Monitoring allows you to catch anomalies early and react before they turn into bigger issues. For instance, if the error rate of your API suddenly spikes, monitoring can alert you immediately so you can investigate the cause before users are impacted. There are several powerful tools available for monitoring your systems. Application Performance Monitoring (APM) tools like Neural and Datadog provide insights into the performance of your applications and services, allowing you to track response times, error rates, and even database performance. Prometheus and Grafana are open source tools that allow you to monitor and visualize system metrics like CPU usage, memory consumption, and network traffic. The key here is alerting. When a monitored metric crosses a predefined threshold, these tools can automatically send alerts, ensuring that you and your team can take corrective action immediately. Proper alerting is crucial so you don't miss critical issues but also don't get overwhelmed with false alarms. Now it's time for an activity. Take what you have learned so far and apply it to one of your project modules. Focus on implementing error handling through meaningful domain-specific exceptions where necessary. Then add structured logging to capture important events or errors in the system and make sure your logs are easily readable and informative. Finally, add basic monitoring hooks to track important system metrics like error rates or response times. Once you have made these changes, push your updated code to GitHub and write a brief README explaining your design decisions. This exercise will help solidify these concepts in a real-world context. For further reading, I highly recommend two books. First, Clean Code by Robert C. Martin has a chapter dedicated to exception handling, which can deepen your understanding of throwing and catching exceptions. Second, Effective Java by Joshua Block is an excellent resource for learning best practices in Java, including effective exception design. Additionally, check out the official documentation for logging frameworks like Log4j and SLF4j, as well as monitoring tools like Prometheus and Grafana. These resources will provide more detailed insights into the tools and practices we discussed today. Your homework for today is to audit your current project and identify areas where error handling could be improved. Look for places where exceptions are missing or generic exceptions are used and replace them with more specific ones. Additionally, improve your logging by adding more context to critical operations and ensure your logs are structured properly. Finally, consider adding monitoring hooks to track system health. This will help you proactively address any issues and improve the maintainability of your system. To summarize today, we have learned that robust error handling ensures that your system can recover gracefully from unexpected failures. Effective logging allows you to trace system behavior and debug issues when they arise. Lastly, monitoring helps you keep an eye on key metrics and take action before a potential problem becomes a crisis. These three practices are indispensable in real-world systems to ensure they remain stable, reliable, and maintainable. Thank you for your attention.